Welcome to inquiryHub Biology. I'm Kate Henson, a former high school biology teacher, and I'm so excited to share this incredible resource with you. inquiryHub is a partnership based out of the University of Colorado at Boulder. Our team is comprised of researchers, teachers, and district science coordinators who collaborate to create and implement story-aligned curricula aligned with a framework for K-12 science education and the next generation science standards. All of our curricular materials have been co-designed with practicing teachers who pilot everything we create and return to the team with their feedback so we can create even better learning opportunities for kids. Co-design is a term that comes from the design-based research community. Our research is ongoing as part of our long-term research practice partnership. Each year, we revise the units on the basis of evidence related to usability, the student experience, and student outcomes. Each year, we gather pre- and post-test data from participating classrooms to analyze growth in the curriculum and present results to districts and submit our studies for peer review. All of our materials are free and available on Google Drive. Teachers can download what they need from Drive and can make productive adaptations that help them support the students in their classrooms. We've created tools to support teachers in this process, and they're embedded throughout the curriculum. The inquiryHub biology curriculum supports culturally responsive teaching. We used evidence from student surveys to select phenomenon, examining data about what most interested different groups of students. Throughout the curriculum, teachers elicit and make use of students' own questions and their experiences in instruction, which supports student motivation and agency. Design challenges give students an opportunity to use engineering practices to connect what they're learning in science to problems of personal, community, and global significance. inquiryHub is research-based. Research supports the idea that students learn best when, rather than transmit information to students about how the world works, teachers facilitate an environment where students have the experiences they need to construct their own explanations and are guided through that process. At inquiryHub, we're committed to developing materials aligned with the NGSS. This means that all of our materials attend to the three-dimensional learning, including disciplinary core ideas, science and engineering practices, and cross-cutting concepts. Phenomenon and design challenges have a central role in our curriculum, and our units are designed for incremental sense-making, which supports coherence from the student perspective. inquiryHub resources support equitable participation where teachers have multiple opportunities to elicit and interpret student thinking. Finally, we support teacher learning through curriculum-embedded resources and live support from the inquiryHub team. At inquiryHub, we use a storyline approach which supports pedagogies that have a broad base in research on how students learn. Problems are presented before students have had a chance to learn core ideas, creating a need for developing an understanding of core ideas. Each unit is a storyline. A storyline is an instructional unit that is a coherent sequence of lessons in which each step is driven by students' questions that arise from their interaction with a phenomenon. inquiryHub Biology has 3 units: evolution, genetics, and ecosystems. Each unit has a central driving question. In evolution, that question is, why don't antibiotics work like they used to? Students work to figure out the answer to that question as they progress through the unit. Within each unit, there are 2 bends, and each bend begins with a new anchoring phenomenon and driving question. In evolution, these are, how did this little girl get so sick, related to how a little girl named Addie contracted MRSA, and what is happening in this new case of the UCSD juncos, related to how a population of juncos, who usually live in the mountains, came to live on a university campus. Throughout both bends, students build a progressively more sophisticated understanding of evolution. In genetics, the driving question is, how can science be used to make our lives better? In Bend 1, students begin by figuring out what is happening to kids who have Duchenne muscular dystrophy. In Bend 2, they figure out how the technology CRISPR works and might provide solutions to problems related to genetics and health. Throughout the unit, they are building an understanding of the big ideas associated with genetics. In the ecosystems unit, the driving question is, how do small changes make big impacts on ecosystems? The first bend focuses on an anchoring phenomenon related to what has been happening to big animals in the Serengeti for the past 4 decades. This sequence, the second bend, focuses on how trees can reduce the negative impacts of human activity related to climate change. While figuring out the answers to these questions, students build an increasingly more complex understanding of how ecosystems function. Utilizing Google Drive, we developed a landing page for inquiryHub Biology. From the landing page, users can access the materials associated with each unit, as well as the front matter for the curriculum and units. The front matter is a place where users can find support for inquiryHub Biology, including planning resources, instructional routines, classroom discussions, vocabulary, differentiated instruction, as well as support for the use of curricular tools like the incremental modeling tracker. Each unit landing page provides links to the storylines for each bend, the teacher handbook, the front matter, assessment, and materials list. The unit skeleton provides a visual overview of where the unit is going, lesson by lesson. The storyline is mapped out in a table with columns that help teachers quickly identify the lesson questions, the lesson phenomenon, the performance expectations we're working towards, and what we figure out in that lesson, color-coded by DCI, SEP, and CCC, as well as new questions and next steps. In this example of lesson 5 of the evolution unit, the unit question is, how do bacteria grow? The phenomenon is related to bacterial growth in the Petri dish. The performance expectation we are working towards is related to developing and using to generate patterns and supportive explanations of how the bacteria appeared so quickly, and to predict scale and quantity of a population size of bacteria in our Petri dishes. Students figure out how bacteria grow and reproduce, how to construct a mathematical model to predict change in bacterial populations. In their next step, they'll investigate the effects of competition for space on bacterial growth and trait distributions in the population using a computational model. Each of the lesson icons is linked to a folder full of resources that includes a teacher guide, slides, student activity sheets, assessments in English, as well as all materials in Spanish. As part of each unit, there's an incremental modeling tracker, which helps students identify how the day's lesson is helping build towards an explanatory model of the anchoring phenomenon. This tool also provides teachers with evidence that allows them to formatively assess student progress. Teachers can monitor progress towards students' grasp of the core practice of developing and using models through the culminating assessment tasks for each bend in the storyline and the accompanying scoring guides and rubrics. Students are expected to construct an explanatory model that includes all elements of a scientific model, accurate descriptions of the components, interactions, mechanisms, and boundaries of the system being modeled. In addition to the multiple assessments embedded in the materials that can be used for formative and summative purposes, we've developed exit tickets with multiple choice questions that assess both student experience and understanding, as well as three-dimensional transfer tasks in which students apply what they have learned to a new phenomenon. The inquiryHub curriculum is built around curricular routines, which students experience and become familiar with as the school year progresses. Each bend begins with the anchoring phenomenon routine, where the teacher presents the phenomenon to students as a puzzle to be solved, and students begin to generate the questions they'll need to answer to solve it. The navigation routine happens at the beginning and end of a lesson. Teachers signal this routine by asking students to articulate what they figured out in the previous lesson and what questions they still need to answer. The investigation routine, as students begin to answer the questions they posed in the anchoring phenomenon routine, they engage in science practices to make sense of the phenomenon and then develop their science ideas as part of the explanation. In the problematizing routine, the teacher seeds, cultivates, and capitalizes on an emerging disagreement that reveals a potential problem with students' current model to get students to focus on an important question that could extend their model. In the putting the pieces together routine, students take the pieces of ideas they have developed across multiple lessons and figure out how they can be connected together to account for the phenomenon they've been working on. From here, they can relate to new phenomenon. The anchoring phenomenon routine has become one of the hallmarks of a storyline curriculum. It consists of 4 parts. Students are given an opportunity to explore the phenomenon. They may watch a video that describes and introduces them to the problem. Next, they attempt to make sense of the phenomenon. Here they might make a timeline of what happened during the course of a series of events. Third, they identify a related phenomenon. Students have an opportunity to make connections between their lives outside of school and their prior knowledge. Finally, students have an opportunity to identify the questions that need to be answered to explain the phenomenon, the questions that will drive their learning for the rest of the unit. The driving questions board is the artifact that's most associated with this routine. Throughout the curriculum, teachers will find built-in opportunities for professional learning about topics such as classroom discussions. Unique icons help teachers navigate through these resources. In addition to curriculum-embedded professional learning, the inquiryHub team provides in-person and virtual support to teachers. Our most popular professional learning package includes a summer workshop and follow-up days throughout the school year. We're excited to hear from you and talk more about inquiryHub biology. Please connect with us. Email us, visit our website, join our communities on Facebook and Twitter.